applied crypto hardening with Aaron Kaplan, Ramin Sabet, Adi Krigic, and Daniel Kovacic.
Okay, thanks. All right, so I guess some people will succumb, but we'll start anyway already because it's supposed to be rather short for our talk. So, all right, so the project is about applied crypto hardening. The word applied comes, of course, a little bit from, Bruce Schneier's famous book. And why do we do this talk? Why did we form a group of multiple people checking common crypto settings for web servers, mail servers, etc.? Is of course because of what happened recently, and we believe that it's better to just protect your systems and don't give them anything for free. For free is really literally, if you look at for example, the fiber optic cable listening that we heard about. Then you know that most SMTP to SMTP traffic on the network is unencrypted. It's really literally for free. So we don't believe that's good. And who are we? When I say we also said we make the talk together, multiple of us who are here at the DeepSec conference, because we formed a little bit of a group. I believe it's very important to have multiple people checking crypto best practices and settings independently right now, because that's in an open source fashion, because that's pretty much what will maybe save us in the cryptocalypse. And there are a couple of people involved in this project. Here are the names. Okay, so what's the idea? So we want to do at least something against what happened. We want to check SSL, SSH, PGP, all kinds of crypto settings for the target group of system administrators, because those people can usually have a bigger effect if they configure the mail servers, their web servers, etc. properly. They have a good effect on their users. So it's a multiplication effect here that we see. And so we started to look, it started originally with Adi asking me a question like, what kind of cipher settings can I still use? What cipher settings are still okay? And we didn't have a good answer, and we didn't find any good documentation on it. We had lots of, good reports from BSI, ENISA, etc., but none of them are in a easy to understand fashion for system administrators, like a copy and paste setting. And so that's why we started to write this paper. So what do we have so far? And the talk is really all about that paper and the reasoning which went behind it. So what do we have so far? We have a big disclaimer in the beginning, because we're not the best cryptographers in the world. We know that. It's hard to envision that anybody could claim that title. So I think the technique again is to have multiple people checking the settings. Then we talk about in the white paper how we, develop the whole thing in an open source fashion. We have a public readable Git repository, mailing list. Everything is public in the discussion here. Then we talk about basics of cryptography, ECC, and the controversion that we have right now. Key lengths, random number generators, cipher suits, a general overview, like what you should do, key lengths maybe, well, we had that before. So what you should do with, choosing which ciphers to use and where the problems lie. And then we come to the main chapter in the white paper, recommendations on practical settings. So this will be just a copy and paste thing for Apache, Nginx, Light HTTP, etc., for a sysadmin. Now it's really important, and that's why we give this talk, that multiple people review this. So that's really what we want to bring out to you. Then we have a section on tools and some further reading links. So how, as I already said a little bit before, how we developed this, essentially we have a mailing list. All the discussions of all the texts which should go into that white paper are documented on a public mailing list. Anybody can sign up to that. So I encourage you to just sign up to that mailing list. Links will be shown at the end of the talk. We intend to have a complete public review, like announced publicly, even in Heise or some other larger newspaper, saying, we would like the world to check this. And if anybody has, an attack against something, at least, tell us, or if we realize we made a mistake in the paper, we'll just cut out something and make a next version. So public review and your review of experts is really important. Okay, I think I'm going to hand it over now to you. And I was quite short.
Yeah. Thanks. Okay, there are some prerequisites we need to understand why we came up with certain algorithms, especially as mentioned, the controversy around elliptic curves, which is currently heavily under debate. Elliptic curve cryptography is basically an alternative to RSA keys. As soon as in an algorithm constants show up, cryptographers like this terminology, nothing up my sleeve numbers. So you have some constants, and cryptographers want to know where did these constants come from. In this case, in elliptic curve cryptography, this NIST P256, one of the most famous curves, these constants are used, and the SHA-1 hash of them defines the elliptic curve. We know that there are certain curves which are rather weak. You should not use them for cryptography. The curve generated by the SHA-1 hash of this curve is not one of those weak curves, but it could be possible that there is another set of weak curves. In this case, the people who defined these numbers either know this other set of weak curves. This set of weak curves might be rather big, in which case scientists should find this set rather soon, or the people defining these constants knew how to invert SHA-1 hash, in which case we would have a much, much bigger problem. So to sum up, it doesn't look very nice. Therefore, throughout the paper, as soon as we recommend elliptic curve cryptography in one of the cipher suits, we have a footnote telling, okay, keep in mind, you might need to change these settings the next day. Follow the community, follow this paper. As soon as we hear some news, we will, of course, update the paper. Another very, very valuable resource is keylength.com, where you find recommended key length, hashing algorithms, etc. You have a kind of a management overview. If you want to buy an SSL certificate, which key length should you use? Just a side note, these are key lengths which are thought to be safe for the next, I don't know, 3 to 5 years. If you're using a slightly weaker key, it doesn't mean your key is already compromised. Just look up the papers. There are very good references on this site why they came up with these numbers. If your key length is a little bit shorter, check your key length. It might be safe for the next 1 to 2 years. An example. This is how the site looks like. You can choose what type of key you want. For example, in this case, elliptic curve cryptography, and then you see the different papers and pointing out which key length they believe is secure for how long. Of course, this is a dynamic process. Some of the papers are updated very often, some not that much, and you always have to check the site or the paper we are producing.
I will browse through some topics, yes, to show you what you have to consider when you pick your cipher suits. And the first one is forward secrecy. So I give you a scenario. So there, imagine there is a 3-letter agency which stores all your SSL traffic, which is perfectly secure today. But someday, somehow, the TLA gains access to the SSL private keys. Either by a brute force or exhaustive search, or by physical or lawful force. So we learned this from LavaBit, for example. And, you know, and this means that the TLA can decrypt all stored traffic, and it's revealed. And perfect forward secrecy is a mechanism to mitigate these future attacks, which we don't know today. If you read some cipher strings, you will come over these DHE, ECDHE letters, which basically means you Diffie-Hellman key exchange with ephemeral keys. So what does ephemeral mean? Ephemeral means that you choose or generate a new key pair for each execution of a key exchange process. So for each session you introduce with your user, you generate a new key, and your SSL private key only is used for authentication. So this means if this key gets compromised, the recorded SSL traffic is not revealed. This has certainly some pros and cons. It's basically the highest security you can gain against these future attacks, but there is a really significant processing cost to generate all these keys, and therefore you might be forced to use elliptic curve if you can't pay the generation of RSA keys or you use Windows Server 2008. However, there is one alternative. So you can basically change your private SSL key every X days or months, which is really inconvenient, I think. The second topic I'll point to are pseudo-random generators. So although I knew that your network administrator don't have to know the mathematics about pseudo-random generators, he definitely should know that it's really important. Yeah? You always need pseudo-random numbers to get your keys, which you apply then to your crypto scheme. And I will point you to a paper from Hardening and Lestra. So these are two papers published very nearly, which shows that if you generate your public and private key pair on embedded devices, this can go horribly wrong. The paper is called Mining Your Q's and P's. So to generate an RSA key pair, you have to generate Q and P. And it shows that some P's or Q's are much more likely to happen than others. And you have duplicate public key pairs, and so I can deduce your private key. So what we have to learn about this is please read the manual of your embedded devices. Look for the place your keys are generated, and if the entropy pool is big enough, or look for if there are default keys. Regenerate your keys from time to time. Maybe try out tools like HaveG to improve the situation. I like to point out two specific random number generators. ECDRBG, if you see this, throw it away. So this is a really bad random number generator for a couple of reasons. We will point to a paper which describes that. And today, the Intel RNG is heavily discussed, but we don't know enough about this at this point. So we don't know if the statistical data might be biased. Our recommendation would be edit the entropy only goes up, and look for information on this. Okay, I want to point out two attacks. Our discussion, we considered in our discussion, just to get you a feeling. The first one is the Beast attack, which is an attack against AES and CBC mode. So CBC is a cipher block chaining mode, where you basically strip your message in blocks and use a previous block, XOR it with the current block to get your current result. And at the first point, you have to choose an initialization vector. Either it's a nonce or a random thing. And it happens that in SSL 3.0 and TLS 1.0, the IV is the last cipher block of the previous packet. And this leads us to an unchosen plaintext attack. You choose cookies where you know the path and some information in a cookie. And yes, I have to browse really. Okay, the second attack is the crime attack, which is basically a side channel attack. So the attacker gets information based on compressed size of HTTP header requests. It's a man in the middle attack, where the attacker has to mitigate to inject some JavaScript to force the browser to do requests on a certain path, and he forces the user to browse, here in this example, the path 0, and if he will brute force the cookie, the session cookie, and if he guesses right, for example, the compressed size of the HTTP header will be smaller, and so he has an oracle. And so we have to recommend that you switch this feature off. Okay, now Ramin will go on.
Okay, from what you've learned so far, we can do some general assumptions. Disable SSL 2.0 because of the weak algorithms, disable SSL 3.0 because of the beast attack. But now we see that we already are losing clients. In this case, all clients which are using the Windows XP Cypher suite, namely Internet Explorer. Enable TLS 1.0, disable TLS compression as we just learned, and maybe implement HSTS. HSTS, usually when a client connects to Google, the user only enters google.com. So the first round trip to the server will be unencrypted and unauthenticated. With HSTS turned on, the server will tell the client that every time you visit my site, add HTTPS automatically. So a man in the middle would not have the possibility to investigate every first round trip to the server. As already mentioned, the stronger the algorithms get, the fewer clients will support this. So we came up with two variants. Variant A for fewer client support but higher security. Variant B for more clients. As the algorithms got stronger and stronger, we recognized that fewer and fewer clients, of course, could support this. So we said to ourselves in our discussions, does it make sense to have this variant A? But we still think that it's okay to have this in our paper because of some situations where you are in a corporate intranet, for example, you decide which clients will use your server. So you decide if they support this Cypher suites or not. Same for an extranet, or when you know that your clients are early adopters, they will always have the newest browsers. If you want everybody to use your site, use variant B. Here we have some examples how the paper will look like. At the beginning, you will have the Cypher suite string we recommend. In this case, the administrator can just copy this to his client. This is just work in progress. And the table below shows the ordering of the ciphers which are chosen. And in the columns, you will see, for example, the key exchange which is done, if it's an ephemeral key exchange, which type of authentication, which type of cipher, and finally, which hash has been chosen. And below that, the problem you will have with your clients, which clients are supported. This is just work in progress. We are currently checking mobile clients and so on. Variant A, only the newest browsers are supported. Variant B, cipher string gets much longer. As mentioned, the ordering is really important. And in this case, most of the clients will be able to connect to this server. One very important note, we also will add which version of the server we tested this with, and we will add some information if you use a little bit older server, which maybe does not support the first or second cipher, if it's a problem for this server, if it will just ignore this configuration, or if it will give an error or something like that. Okay, and variant B, more or less maximum compatibility. But you see still that there are some situations where we say, okay, that's a business decision, business trade-off. In this case, we said, okay, we do not want to support Windows XP because it's more or less end of life. Java is a problem we are working on. We don't know how to support this, and one of the places where we would love your feedback.
Cipher string in version B actually is built in a way that it's really copy and paste. So if we could just go back 2 slides, I'm sorry. You might notice here at the very end, there is a non-ephemeral cipher there. This is meant to be for those sysadmins who just do copy and paste, because that way the same clients are supported even with very, very old versions of OpenSSL. And that's also the reason why we added, or why we explicitly removed some ciphers from the list, just to be on the safe place for those doing copy and paste. For whoever cares, it's a very good idea to choose your cipher on your own, which actually means you first have to choose the key exchange, which should be, even BSI recommends it, should be an ephemeral key exchange, be it Diffie-Hellman key ephemeral or elliptic curve ephemeral. You have to choose if you trust NIST curves, or probably time will show. Then there are some known weak hash functions like SHA-1, which is probably okay when used with ephemeral Diffie-Hellman, but should be replaced with SHA-2 or even better SHA-3 in the near future. But this actually lacks client and server implementation at the moment. So you will be pretty alone with your server when you just enable TLS version 1.2. Then there are some issues. We only showed up to now OpenSSL cipher strings. There are some other SSL libraries like GNU-TLS, which of course uses different syntax for specifying a server cipher string. And we also have the situation that some distributions like Red Hat Enterprise Linux, for example, disabled elliptic curves for, I guess, 5 or 6 years now, and they just recently started to enable them. So it might be necessary to individually check on your server and your machine what ciphers are supported, what ciphers are used by which clients, which server software, and which clients support it. Okay. Another thing for the TLS standard itself, there are quite a few ciphers specified, like not only IAS, but also Camellia and ARIA, of which only Polar SSL at the moment implements, I guess, pretty much all different combinations of key exchange, hash, cipher, and authentication mechanisms. It would be great for the near future. I don't know if some of you develop a crypto library, but it would be really great to have some more ciphers, some more hash functions and stuff like that in about every client and about every SSL library, just to be on the safe side in case someone breaks Camellia, IS, or whatever. It could be possible by a new kind of attack vector or whatever. So when you choose your cipher, it's a really complex situation you're in. On the one hand, you can just take the TLS standard and say, yeah, that's what I want. I want ephemeral Diffie-Hellman, and I want Camellia and IES, probably SHA-2 and whatever. And then you have to start looking for your server libraries if they support it. If all the clients you need to support are able to deal with that, in case you're in the situation that you have to support Windows XP, for example, there could be a trick that might help you out of this by, for example, using the inability of Windows XP to understand SNI, which is kind of virtual hosting for SSL. And you could just add a default site with very weak ciphers, telling the user to just upgrade to a reasonable browser or reasonable crypto stack, and things like that. So that you're on your own to choose from. And you should never forget that, for example, Outlook is using the Windows crypto stack too. So there are quite a few clients depending on that. Aaron will later show all the systems we're taking care of describing it. Okay, for the future, we're thinking about adding kind of a config generator that helps you in choosing whatever you want, specifying the clients you want to support, and then in the end get out a quite reasonable configuration that might work, I hope. Yeah. Okay. Practical settings.
All right, so we were quite fast actually. You know, when we developed that paper, it was like we were discussing so much about the different settings, and it took really some time to come to some agreement. And we're still not sure if it's the best proposal, is variant A or variant B. But anyway, we you know, focused on practical settings for different web servers and different mail servers. So what do we have so far in the paper? We pretty much covered the important web servers: Apache, Nginx, IIS, and Light HTTPD. The most important mail servers: Dovecote, Cyrus, Postfix, Exim. There was some submission for MySQL, and also for proxies. So for man-in-the-middle proxies, I would call them like Bluecoat or well, Squid. In a corporate environment, you need to be aware of that, because especially for proxies, if you're in a large organization, you want to connect out, then you have some compatibility issues with let's say the web server out there. And that's a special situation, actually. What we're still missing, or where we just have like the beginnings, is for the mail server Exchange, of course. So if any one of you here is a specialist on Exchange, and you want to contribute to that paper, it's important. You know, I don't like that mail server myself, because of some issues, but many people use it. So it's really important to have that documented. SSH, for example, if Kyra travels to some interesting countries and she wants to SSH out there, so I'm really happy that she listened to that talk now, because it's critical, you know, if you connect out there. And everybody thinks, like, I thought by default SSH, that's this good crypto stuff, right? It's SSH, and I'll just tunnel any command over SSH. But in fact, it just uses the same cryptographic primitives. So if they are attackable and the ciphering ordering is like that, and there are some, you know, downgrade attacks, then you have the exact same security. VPNs, lots of stuff here, especially because there are so many to choose from. Cisco has its own variation of IPsec, etc., etc. PGP. There are some very good recommendations. There are some very good recommendations for PGP by the Debian project, especially because SHA-1 as a hash is phasing out, and many people still have SHA-1 in their PGP settings. Big can of worms, IPMI, integrated lights out systems. Our recommendation here is, like, don't trust the crypto on those. Just keep them off the network. Keep them to contain to a private management VLAN, and that's it. Never go directly there, because very often what you have is like a small embedded system on that card, and it will end up with really bad random number generators. I think whoever was in the talk before by Peter, he had that as on his list of top 10 software design programming errors, random number generator errors. You will see those in here. Another big can of worm is VoIP and SIP. And eJabberD also is working a lot right now to secure their settings. So that's good news. And we also need some more support for different database configuration snippets. So when you look at the white paper, you'll see like just simple just simple snippets of code where you just go cipher string equals blah, blah, blah. then some other things like I don't know, hashing, whatever, and then it's very simple to copy that. Okay. So testing, how can you check your own web server? Because we all like to tune and find out like what is the best setting, especially after Adi's part where you have the small recommendation of how to choose your own cipher string. Then it's really fun to actually check that and see what you can improve. So there are a couple of nice tools for that. First, the built-in S-client from OpenSSL or the equivalent in GNU TLS. That's a command line tool. The second thing is a very nice website by Ivan Ristic, sslabs.com, and you can check any web server there. So you just go, let's say if Kyra twitters, okay, and want to check the security of Twitter, right? So you just go sslabs.com, analyze the web server, just enter twitter.com, and you get all the the flaws that they have there, which are known in literature. But they might have chosen intentionally to just accept that because of compatibility. So it's interesting to see, because you can see what kind of downgrade attacks or other attacks are theoretically possible. For chat service, xmpp.net has the same. It's just for Java XMPP service. There's a command line tool called SSL scan, which is also very nice. And a new one which I heard about just yesterday at night. SSL dice. I still have to look at that. Okay, so how does it look like? The built-in command from OpenSSL looks like that. You just give it essentially a domain and a port, and it will connect there and try to speak SSL or TLS, and you get all the data from it. Same for SSL scan, which does this complete check command line tool, and SSL Labs looks like that. So after tweaking with our strings, we achieved that result. We're pretty proud of that. It's not 100% perfect yet, but it's quite good. And you can see it supports TLS 1.2, 1.1, 1.0, and ignores the other ones. Here are the cipher suits that we recommended before in variant B. And then you get the results of compatible clients. That's the most important decision for a sysadmin. Whom do I need to support? What are the risks? What can I, what are the compatibility issues? And essentially you can test that with that tool. Okay. Any questions so far? Okay. Then let's wrap it up. So where are we now? We started with this paper where, a group of multiple eyes check that and write that collectively. So we have a solid basis now with variant A and B. The table of contents is in a sort of a free state now, so unless there's some really good reason, we don't like to change the table of contents of the white paper anymore. But there's still some sections missing, as I said before. Some sections still need more work. We're aware of that, yeah. We hope we'll finish that properly. And that brings me to the point where you get in the game. How can you participate? Well, what we need is like cryptologists, system administrators, people from the practical side, coders, hackers, and we would like to ask you to just read the document first to get an understanding what we were thinking about first, Then if you find bugs there or if you object to some of the settings, please, by all means, tell us. So subscribe to the mailing list. It will be a public mailing list with a public archive. And if you figure out that one of the sections you could add something because you're a specialist in that field, please just send us a diff on the mailing list and propose your text. And there might be some discussion about that, but that's the rule here, that's the game, and that's why we like to keep that public, because it says something about how we open source, keep it clean, keep it checked. So we don't have any doubts anymore than afterwards that something sneaked in secret. Yeah? We just want to avoid that. So the scandal with the ECDRBG NIST standardization issue, we want to avoid that. Of course, we don't standardize anything, but anyway, we want to, at least for the recommendations, we want to avoid that. That's why it's public. And most important, as I said, I think a couple of times, reviewers is really important. So that brings me pretty much to the end. Here are the links. There is a small initial website describing the project, FAQ, link to the Git repository, mailing list, and that's pretty much it. Okay, so thanks. Any questions?
Any questions?
Thanks for your talk and for your project. It's a good thing, I actually think. Two things. At first, you should add a section about password encryption in software, because I've seen a lot of wrong things done there by individual programmers and by Linux administrators. The numbers I'm seeing, MD5 hashes in shadow passwords, there are a lot of systems. So that's one thing you should deliver it to add to your white paper. And the other thing is, I think it would be good not only to publish the white paper, which is a kind of let the sysadmins come and read it approach, but to push sections of the white papers into the Apache manuals, into the hardening guides, into the php.net and whatever the sites are where the sysadmins and programmers go to. So trying to bring the security to them and not telling them, hey, it's a paper, you can read it or leave it, because most of them will leave it anyhow.
And at the end, make it as a default setting for the distributions. I mean, why not?
Sorry, say it again, please.
And at the end, after pushing them to the man pages, they should be the default setting in the distribution. I mean, yeah. Why can't I A2N mod secure variant A or variant B, so that I have a module for my Apache to enable it?
Thank you. Yeah. I'll try to answer the little bit to your two suggestions. You know, putting it to the default manuals and so is like, you have to remember that this is, any recommendation that we have here might change overnight, because something gets known, some attack gets known which wasn't there. So what is actually, I think, really important is to think about the life cycle about that. So even Ristic from SSLLabs.com did a great job already, because he actually provided tools for anybody to check on the internet. And this ties into a nice life cycle. So I think we need to think more about that. And the second comment to your first suggestion, to the table of contents, do you mean more like, you know, how passwords should be saved, let's say in a web application, in a database like MD5 hashes or whatever, or not MD5 hashes, yeah? Something like that? Do you mean that?
In terms of password encryption, there are actually two types we see. One thing is that most software can be configured to store passwords in some way, especially Linux operating systems. There are multiple configuration options how the passwords are stored in the shadow file. That should be addressed. And on the other hand, a lot of programmers that build their web shops and whatever are trying to implement passwords, are storing passwords, and you won't believe what you see if you check what they are doing there. So some recommendations.
Okay,
it
all right.
would actually be twofold, yes.
So how to, but that addresses more like the programmer, right? Or also system? Okay, the system, okay. I think it's a very good suggestion. Just wanted to understand in detail what you meant, yeah? Okay, do you want to add something here? Or no? Okay. Yeah, thanks for the suggestion. Okay.
I also have a question, comment, suggestion kind of thing. So you have mentioned by going into version A and version B, you have addressed compatibility issues, right? And I was wondering whether you are also thinking about going to address any performance issues that come along when implementing, say, perfect forward secrecy, if we just compare Diffie-Hellman to elliptic curve Diffie-Hellman to standard elliptic curve algorithms that are very important for maintainers of applications that run on, say, not the top-notch latest revision iPhone, that will very much impact the performance of the application on the device. So I'm wondering as to whether you're going to put any performance recommendations or results or kind of ballpark numbers, because really you'd have to test it anyways into your documentation.
I think that's also a very good suggestion. So no, so far we didn't think about that yet, honestly. I think we did a little bit maybe that, you know, yes, we know some of them are more computation efforts, but we didn't like do any real measurements yet so far. Yeah, go ahead.
There's a very good paper from the author of GNU-TLS comparing the numbers. You already know it, okay. We did some considerations in that direction, but I think that might be too much for the first version. We will just address the security at the beginning, and maybe for the later version we will also consider the performance issues.
I think is that even if you don't put the numbers in, right, because the numbers will vary greatly depending on your server setup or your load balancing setup. But if you put in the fact that that actually impacts a lot and ways to test as to how these impacts might influence on some of these implementation, that would probably be already very great.
That would be a very good first step, yeah, thanks.
I would still like to add something there. I think, you know, this testing approach, we just focused in the beginning of getting the basics right, and we're still not there yet, yeah? So it's really actually, you know, since we said we want to have multiple people involved in that, it becomes, of course, a more time-consuming process, but that's good, because all of us learn, all of those people who participate in that way automatically learn, in addition, things that they didn't know yet. None of us knows everything about that. It's a really tricky subject. Like like Peter from the talk before said, getting crypto right is really not easy, and he said, like, many people try to implement it on their own, many programmers, and that's the big no-no, right? So none of us knows all these things. So all that we can really do is like get involved in that process and learn more, and also have a testing mechanism that we can, like SSL labs, for all kinds of different things. So your suggestion would be like to add testing capabilities for performance. I think that's a very good idea. And it's like, you know, you try to explore the cosmos, in a sense. You don't know what's really out there. We don't know what's broken in crypto until we really see it for ourselves, or somebody screams, wolf, you know, be careful here, right? So that's what we are doing, yeah. So, right, thanks.
Thank you very much.